welcome to PhysChem with Liz. I'm Liz, and in this video we're going to do a worked example together on calculating an enthalpy change from using enthalpy change of formation data. So if you haven't already watched the introductory video on Hess's Law, that's a good place to start unless you're comfortable with the introductory knowledge and you know how and when and which cycle to choose when applying Hess's Law. So in this question we're given this delta H formation data and we need to calculate the enthalpy change for this reaction here. Okay, so we've got ethene gas, we're combusting it, burning it in oxygen to produce carbon dioxide and water. So these are always the combustion products of hydrocarbons. Now, so since we're given formation data, it's that cycle with the elements at the bottom. Now, you don't even need to write the elements, what they are, to get the marks in the exam, but since we're here, let's do it anyway. So to make a hydrocarbon, obviously we need carbon and we need hydrogen. So hydrogen in its standard state is a diatomic gas, so make sure you write that. And then oxygen, just oxygen. Okay, let's balance it. We've got two carbons there, so we've got two there. So it only needs to balance with one of the sides, if that makes sense. So we've got two carbons there, two there, so we only need two here, not four. Okay, now we've got four hydrogens, so two H2s, that's four, so that's balanced. And six oxygens, so put a 3 in front of that or 2 to make 6. So that is our cycle, and that's labelled our delta H over the arrow. That is what we want to calculate right there. So our next step is to identify our root 1 and 2. So we look at the arrows and we can see we've got these two that are going in the same direction. So let's call this root 1. Then we've got another arrow which is going counterclockwise in the opposite direction. Let's call that root 2. The next thing we do, Hess's law says that root 1 is equal to root 2. So we set up an equation. So root 1 equals root 2. And what we do is we collect all the terms that are in root 1 and write them equal to all the terms involved in root 2. So in root 1 we've got ethene and oxygen and this delta H. So we've got one lot in the balanced equation of ethene, so we write plus 52 plus, ready to collect the next term, 3 oxygens. Now we're not given any data for that because you cannot form an element, so you will not get formation data for elements because they're already in their simplest form. You can only form compounds from elements. So that would be 3 times 0, so we'll leave that out. So plus delta H, that's part of root 1 as well. Then we write it equal to root 2. So what have we got in root 2? We've got 2 lots of carbon dioxide and 2 lots of water. So we have to times each of these values by 2. So 2 lots of minus 394 for carbon dioxide plus 2 times minus 242 for the water. Now, it's a good idea to work this side out first on your calculator. I'm going to rearrange. So what we do is, it's just an equation, so what do we do with it? We rearrange in terms of the thing we want to find out, which is delta H. So delta H moves over here to the left, well it's already on the left. So what we're going to do to get that by itself is move this plus 52 to the right. Remember, change sides, change signs. So when that comes over there, it becomes minus 52. So pop that in your calculator. In fact, I'll try and do it on the camera. Just to in it. Okay. Hopefully you can see this. So 2 times minus, let's do it properly with brackets, 2 times minus 394, close bracket, plus 2 times minus 242, close bracket, equals minus 1272. So let's write that down. So the answer to this bit is minus 1272. Now we're going to move that plus 52 to the right, so it becomes minus 52. Then what we do is pop that in our calculator. So we've got minus 1272 minus 52, because it's moved sides, it's changed its sign, and we get minus 1324 kilojoules per mole, and that is our answer. So in a nutshell, what we did, this was our reaction that we wanted to find the enthalpy change for. We were given the balanced equation. We were given the formation data. We constructed our cycle by putting elements underneath. You don't even have to write what the elements are. You can just write the word elements. You'll still get the marks of the cycle, unless it specifically asks you to write them with the state symbols. Then there'll be marks awarded for that. So our arrows are pointed up from the elements of the compound. We labelled delta H over the arrow for the reaction that we want to find the enthalpy change for. We labelled our route 1 and route 2 by looking at the directions of the arrows. So one route where the reactions go in one direction, the other route where the arrows go in the other direction. Then we wrote that Hess's law says that route 1 is equal to route 2. We collected our terms involved in both of these. If there are balancing numbers in front of that thing in the equation, then we make sure we times our values by these. And lastly, we rearranged for delta H to get our answer in kilojoules per mole. So that was a worked example using formation data to calculate an enthalpy change using Hess's law. I hope you found that helpful. If you did, please like and subscribe. Thank you.